Hey everybody, thanks for joining us. We'll go ahead and start the webinar. This is Brian Flannery speaking. I'm the community manager for NATS, and we're joined today by Dennis Mårtensson, who is the co-founder and CTO of Gretas. So I will obviously let Dennis speak quite a bit more and introduce himself and tell us a lot more about what they're doing, what they've built at Greta, and some of how they're using NATS. Just some quick housekeeping items before we dive into that. So we'll make sure to record the webinar so that if you guys want to also digest it afterwards or share it or have any questions, we'll make that available. So you can expect to see that in the next few days. I'll get it out to everybody that's attended, and we'll share it, obviously through the various social media and Slack channels we have. As far as questions go, I'm going to let Dennis explain a lot more about what they've built, and I have some questions that I have that I'd like to discuss with him. But at the end, as time permits, we will also open up the Q&A to the group. So if you do have any questions, you should see a question box there in the GoToWebinar app. Feel free to just go ahead and ask a question. I will see those, and I can go through those and get through as many as we're able to get through. So with that being said, I'm going to go ahead and turn it over to you, Dennis, and let you take things away and walk us through the company you've built, the platform you've built, and how you're using NATS.
Yeah, thank you. So Greta is a Swedish company, and we are based in Sweden and Glasgow. So I'm going to talk to you a bit about how we are using NATS to change how data is distributed on the internet. So just some brief stuff about myself. I work for a company called Storytel. It's basically Spotify but audiobooks, and it's big in the Nordics and Eastern Europe. I went to the university here in Sweden, I went to hacker school in New York, and then we founded Greta in 2015, so still quite young. What you get with Greta is basically that you load data at a higher quality, you get shorter load times, less buffering if you're streaming video. That's the same for the higher quality. You also do this by offloading your servers because there is peer-to-peer in it. So basically how it works is that if you have a network, this is like an arbitrary piece of the internet, basically. So the squares with the white dots represent users in different geographical areas, and they are connected to different ISP, internet service providers, which peer with each other and connect to the rest of the internet, a few IXPs, internet exchange points, basically. So normally, all of these users will go up the network until the content is hosted in a data center or CDN or similar. But Greta sort of switches this by saying that if you have the content, you can share it to other people. So you can do that inside geographical areas or cross geographical areas, cross ISPs, but basically the goal is always to put the distribution as close to people as possible. So if you ever heard of people talking about that the CDN POP is in the last part of the network, this is absolutely the last part. We had cases where we're inside the same network or inside the same buildings or in bigger apartment complexes, sharing content in different levels in the network, basically. So say that if we are down in the ISP1 here to the left, basically one of them have gone to the server to get the content, and then it distributes to the other person. And this gives you the benefits that we read about with higher quality for video streaming and less buffering. And if it's an e-commerce site or similar, then you get faster load times for your static resources like images. But how do we do this, and where do NATS come in? So a normal user would load the web page from the server as normal, and here you include the Greta script in the response. Then it will go to our API to get some metadata about itself. So it basically gets this is my ISP, this is the configuration for this customer in the Greta network, and some peers to connect to. So you get that back, and here is the signaling system that we built. So in webRTC, you need to use something called ICE and answers and offers to set up a connection. And the signaling system is the manager of that. So we built a system that has Go as a proxy between WebSockets and NATS TCP connections. And then we basically send the commands from the client into the NATS server. We do some sanitation on them, but we send them in there, and then we trust NATS to route them to the other peers that are connected or listening on this channel and back to their clients through the WebSocket connection. So when you bring in another user, in this case, user 2, they will go through the first steps exactly like the ones before them, and then when you find each other, they will start the process of exchanging offers and answers. So in this case, user 1 will create an offer and send that into the signaling system. And to get this to work really, really fast, you need it to be globally distributed, and you need it to be super fast software and also super scalable. We've written a blog post about the scalability we've been able to get from a system built on NATS. It's quite good. We like to get it higher, but it's good at this point. Basically, this process is the biggest time chunk in setting up a peer-to-peer connection, and that's why you need a super fast signaling system. So, because you can't act until the other one have received the last message, basically. So user 2 gets the offer and creates an answer and sends it back through the signaling system to the 2 users. And then they set up a peer-to-peer connection through that process. So that's where the signaling system is important. When you have the connection between them, you are actually using true peer-to-peer. So then they exchange some information about themselves with each other and what content are in the DHT or the distributed hash table for the different users. And then they can start to request content from each other. So user 1 can then send a request for a piece of video or an image. Instead of sending it as a GET request to the server, it sends it to user 2 that will then respond with the content for that request. And every time Greta is about to load a piece of content in the client, we try to figure out what's the best way of getting it by using a few parameters and a bunch of calculations on the network and things we know about the network from now, but also from before. We collect roughly 100 million points a day around the network and how the internet is performing for our customers, and we utilize that to make the steps and the decisions Greta make even faster and even intelligently. So this is all the steps and how it's working for 2 users. Obviously simplified with just having 2, but you do this basically for a bunch of users that are good peers for you to connect to. So you get a lot more messages. We pushed our signaling system to above 10 million users with having NATS as the backing and this Go proxy in front. And it's been acting very, very well for us and stable, which is the most important part when it's in production and global. You implement Greta quite easily by adding a script basically to the site, and what happens then is that we will connect you to our system and start collecting data. We won't touch the distribution until you tell us to, so you can get like a feeling about how you are performing and what your capabilities are today, and then you can test Greta in one geographical area, or you can turn it on for your entire user base. And I think that's a brief overview of what we do, and we can take some questions.
Excellent. Well, thanks, Dennis. Appreciate it, and with some interesting data points in there. I know you referenced the blog post you've done earlier in the year. I remember on the Greta script blog, and I believe you gave a pretty good overview of at that time sort of the journey you've gone through to get to Go and to get to NATS. But I was just wondering, maybe some things have changed or maybe they haven't, but what are the major components that make up your back-end infrastructure stack? Be interesting to understand that.
Yeah, so let's bring back, we can take any one of them basically, but let's take like this one maybe. So for the API part, that's backed by some big data tools, but to get like the data out of the network. But the front of it is built in Node.js to respond to request and collect data basically. The signaling system is, as I said, built on NATS and a Go proxy. One thing that we haven't talked about that changed a bit is that we started utilizing NATS for parts of the API as well. Especially like when everyone is connected to the signaling system and we can handle a massive amount of concurrent connections, we can actually allow our users to send events down to the users in a really interesting way, where like you can send a command to our API, like purge everyone's cache, or change this parameter about the configuration, or do changes. You send an event to our API through normal, like either through web UI or through a button, and we then send a signed message out throughout NATS. And in the beginning, we were quite afraid that we put too much strain on the system, because basically what happens then is that, say you have a user with 100,000 connected devices right now, you get one API call in, and that will generate 100,000 messages going out to the clients. But we've done a lot of testings, and it's been super fine, and it gets the messages out really quickly. So we allow our users to like actually change interesting things about their distribution settings, like I want to remove everyone's cache for this image, or I want to change these settings about the network and how it works through NATS and the API really quickly and in a secure way. And we thought that we might have to like cap that and like make it do it over longer time, but it's been really fun.
Excellent. That's helpful. The other thing I was just curious about, and as I said, having previously read your blog post, had some context on, but I know I saw a few questions actually people are already putting in the question box related to this. Was I think people are just curious, what were you doing before NATS? Like, how were you handling the messaging, and how did that piece work prior to NATS? And what was sort of the evolution? What did you try? What tools did you look at? And how did you pick NATS?
Yeah, so we tried a lot of stuff, and we experiment quite a lot in different parts of the system, but in signaling as well. So first we thought that we could use some hosting, like some hosted service. But they all turn out to not really be structured for our use case, and they tend to be too slow. So that didn't work as well as one could have hoped. So then we turned to like figuring out a way to do it ourselves. And first we started out with having an Nginx server that was quite heavily like changed and made it basically push data and work with like server sent events. But that added too much overhead, because you had to send an event to a REST API to get it to be published out to the clients. And that's not optimal when you look at speed. So then we changed over to WebSocket-based systems. We tried RabbitMQ with their SockJS proxy, basically. That was like okay. I would say in stability, as long as the network was good. If we started to like have problems between the nodes or the different data centers we are in, we got into strange places, and it was hard to scale it automatically when usage grows. So as you might like imagine, we have quite like strange behaviors when it comes to like scale, because someone can just add, or also we always have to take everyone's spike. So if we have 3 customers spiking at the same time, we need to be able to do that. So we spend a lot of time on like scalability and being able to scale up really quickly, which this setup with NATS and in Go have allowed us to do. We start pods in our case, because it's in Kubernetes, really quickly using this deploy.
Yeah, it makes a lot of sense, and I know certainly quite a few of the Golang developers are that I speak with are looking at NATS as well. The other thing I was going to, so you kind of touched on where I was going next, was just not only what tools you've been looking at and some of the frameworks, but what some of the results have been. I know you mentioned that it's sort of always available and things have been working. I didn't know if you had any sort of metrics other than the concurrent connections, or any sort of data points or results you might like to discuss?
Yeah, I mean, we measure a lot. We actually, I can't remember who built it, but the person that built the NATS to Prometheus exporter, thank you, it's awesome.
Yeah, I know those guys are actually, there's a couple of them, but I think most of them are located in Germany. I think I know who you're referring to, though, the team at Lovu in Germany, and there's a couple others.
Yeah, it's really good. We use it to get data out of NATS and into Prometheus, and then we graph it. I can't remember exactly, but we do around, like, if you average it over time, I think we are sustainable at like somewhere around 250 messages per second in, and delivering roughly the same out throughout our cluster for like every single cluster as some sort of like scale of how many messages and people we move. We're never below 30,000 concurrent connections to the system in a 24-hour period. So that's sort of some metrics for what the system does for us today.
Yeah, that's interesting, especially in the concurrent connections. And certainly, I'm obviously as a community manager, I'm really close to all of the great work that the development community has been doing out there around NATS. But it's always nice to hear that it's working well for you. Some of the connectors and the integrations they built, like with Prometheus and some of the other ones as well. I'm gonna, in a second, I see several questions coming in from attendees, so I definitely want to get to those. The only other I think area I wanted to understand, or maybe to just let you speak a bit about, was just as we head into 2017. What are some of your goals, and kind of where are you guys going as a company with the product, as well as potentially with NATS? I don't know if there's other services or other things you're looking to build on top of it.
Yeah, so I think one of the most right now, considering NATS involved right now, is the possibility of like in real time delivering changes to the clients. I think we just scraped the surface of that because we can basically, with very, very little delay, we can publish changes or decisions we see on a global scale to the local users or the local clients that normally just react to events happening around them or with peers they know in the network. So we can sort of like add a level of intelligence to the clients in being able to look at data at a broader scale in the backend system and then publish it, so the clients know about changes that happen. I think that's going to be really cool, considering having NATS in it, and also it's going to be cool to see where the limits for like this sort of fan out behavior is. As a company, we are growing quite rapidly in people and usage. We do quite a broad range of different projects right now. We have smaller sites that go on and just use it as is, and we have some really cool, promising proof of concepts with some of the bigger or biggest tech companies out there, which are really exciting, being a small sort of infrastructure company.
Excellent. Well, perfect. So I very much appreciate the overview on the company, the platform, how you're using NATS. I know I've learned some new things as well since I saw your blog a while ago. And I think at this point, I'll open up some questions from some of the attendees. I see several more that have come in. So I'll just kind of go through these in the order I got them. I think we definitely have some time for Q&A. So one of the questions that came up was someone was asking, what do you do when you can't get peer-to-peer? So where does Turn come into play at Greta and S2 stun and things like that?
Yeah, so we use stun, which is basically a way to get metadata about the client, which you need for webRTC. It's sort of, if you remove it, you get very low connectivity success. We never use turn because relaying data over a server is not going to help in like delivering data at low latencies. But basically, you do not have to change anything about your hosting. We work with like all the CDNs and your normal hosting and things like that. So basically you add Greta in between if you have a CDN or S3 or whatever you use for distributing your resources, you add Greta in between. And if we can't find a peer that's better than getting it from the server, or we think it's better than getting it from the server, we will go for the server with a normal HTTP request. The only requirement there is that if you do like cross-domain stuff, you're gonna have to enable CORS, but that's the same if you stream video from like an HLS source or similar to that today. So you don't need to change anything or very little in the Casasant CORS to your current system.
Excellent. You mentioned some of the cross-domain items, and actually the next question that came was related to security, so I think it's probably a good segue. But I saw someone just asking what security features of NATS you guys are using, and I imagine anything related to security of your platform would be interesting as well.
Yeah. So we don't use a lot of the security features in NATS, I would say. We sanitize all messages coming in so that you can only execute certain commands on certain channels or patterns of channels, basically, that are allowed for clients to talk on and with commands they are allowed to talk with. And then in the system in general, we have quite a lot of like, how do you verify that content is the content you asked for and that no one changed it, which is a lot of like, how do you distribute some sense of truth about different pieces and bytes in the network, which we also do.
Excellent. The next question I saw, someone was mentioning, I believe the way it's written anyway, that I think they're saying that they are currently running proxy applications. So they're running some applications that proxy to Go, and they obviously use NATS since it's built on Go. And it looks like they were just wondering if you've ever considered using Node.js for Go as well in your infrastructure.
Yes, so that you would use Node as the proxy between WebSockets and TCPs. That's
how I read the question as well.
Yeah. I think we mentioned in the blog post, but I can't remember exactly how far we managed to push Node, but it's not close to what we managed to push Go to in concurrency. So that's basically why we don't have Node for the signaling stuff. We haven't been able to get the same speed and concurrency levels.
Okay, got it. And I will later today make sure to post if anyone listening in. I think most of you probably follow the NATS Twitter handle, but I'll repost that blog post that Dennis had written earlier this year on Greta site because it definitely covers a lot of really good ground. Because not everyone may have seen that. The next question I saw was just related to your topology and sort of the deployment. So someone was just asking how many NATS instances approximately you run in the cluster.
Yeah, so we have at this point 3 different data centers, and we do not need to proxy send messages between the data centers. So we run 3 like isolated NATS clusters, and they start at 3 pods, and then they can grow if needed. So 9 as a minimum of NATS pods, and then in 3 different clusters.
Okay, and let's see, I think I see, the last question I see is an interesting one to end on, so, but I think a good question, someone was asking, hey, if you're able to answer in any kind of detail, what, if any, limitations you guys face and how you're planning on overcoming some of those. So that's interesting.
I think one problem building a system that quite fast get a lot of usage or high volumes of traffic is how do you structure around being quite a small team and have high confidence in what you release and being able to release quite aggressively, which is a goal for us. So we have at this point gone to using Spinnaker, which is a tool from Netflix that allows you to deploy. It's a continuous deploy system. So it deploys for us to the different clusters, and the clusters are on Kubernetes, which we changed to quite recently, and been really happy with it. Gone down, like made our deploy times go down quite heavily. And Spinnaker is a really good tool to have like good confidence in the system and have everyone trust that the deploy will work. And if it's not going to go through, Spinnaker will end it in a good way and use a good strategy for deploy and rolling back. I think that's a challenge as being a small team with quite fast growing like demands on the systems we provide and host.
Excellent. Okay, I didn't see any other questions, Dennis. So what I just did want to tell everyone who did attend, thank you for joining. Obviously, if, you see Dennis's contact information, so I would encourage you, if you have additional questions, to reach out. And I know that a lot of you are also in the NATS Slack community, so I know Dennis spends a lot of time there as well. So if anyone wants to reach out or get connected that way as well, feel free to ping me and I'll make an introduction. But I really appreciate you taking the time, Dennis, to walk through the overview and also just to explain a lot of the sort of real-world scenarios and lessons you've learned and where you guys are going next. So it's definitely interesting, and we'll make sure to, as I said, share the content shortly, the recording for anyone who's attended who would like to maybe digest that later or share it with anyone.
Yeah, thank you for having me. And as Brian said, like any questions, send them to me either in Slack or at dennis@greta.io. And for the blog post, if you go to greta.io, you also find it in there. It's under blog in the menu.
Excellent. Yeah, and that was a really good post for anyone that's interested in learning not only about NATS, but just some of the other frameworks they looked at, the general messaging, not only pub/sub projects, but also just general messaging projects. So it was a really good blog post, and it's definitely worth another read. It's still very relevant. So I'll make sure to share that as well. But definitely go hit their blog. Okay. Well, thanks everyone. We will we'll be picking up the blogs again. I mean the webinars again early next year. But Dennis, thanks for your time, and great to end 2016 with you, and the questions we had from everyone were great. So thanks for taking the time to ask the question.
Thank you.